All right, I want to work through an example, another simulation example with you before I give you the assignment, let you try a few by yourself. All right, so the example we're going to look at is taking a multiple choice test or multiple choice quiz. The scenario is that you have a 6-question quiz, and then after you've studied, notice they studied, and you estimate that you have about an 80% chance of getting any question right. The question is, what are your chances of getting them all right? And we want to simulate this. If we're just guessing and we know 80% of the material, then what's the chance that I could get lucky and get all questions right even though I don't know all 100% of the material? So we're going to let our numbers and our simulation do this for us, and we'll just see what happens. Note that if you were to do the same thing that I did, your results could very well be a lot different than mine, but they should theoretically be it's around 26%. Now, I didn't get very close to that in my example, but if you were to try your example, some of you would get more than 26, some of you get less, but that depends on whatever happens with your calculator or if you're using a random number table in the back of the book. So we're going to run through those 7 steps that we talked about simulation, and we're going to look at each one. So the first thing is, what are we going to be doing? Well, each number that we generate, or in this case we're going to be generating 6 numbers at a time, is going to represent answering a multiple choice question. 2 says we want to divide up our numbers. So if we have an 80% chance of getting any question correct, then 8 of our 10 digits are going to be dedicated to correct answers, and then 20% are going to be dedicated to incorrect answers. And so you can see here we're going to let 0 to 7 be the correct answer, and 8 and 9 be the incorrect answers. We are also going to stop. Our trial is going to stop after 6 digits because we only have a 6-question quiz. So we're only going to have 6 questions at a time. Repeated numbers are allowed because a number is a generic response. It isn't specific to any specific answer. It simply means it's either correct or incorrect. Part 3. We want to kind of generalize what we're doing here. So it says we're going to be pretending to answer multiple choice questions, and we're going to look at what percent of my 20 trials did I get all of the 6 questions correct. That's really what we're going to kind of do here. Remember, part 3 was just a short summary, or overall, what are we really going to be doing, and make sense of our simulation. All right, part 4 was what are we going to be counting? We're going to be counting the number of correct questions that we get each time. So in practice, what I'm really going to be doing is my calculator is going to be generating 6 numbers, or if I had a random number table, and you're welcome to use either one if you have a random number table. I think I gave everybody one. You could just take 6 numbers and look at what numbers they are. We want to be counting how many numbers did it have between 0 and 7. And so step 5 is actually going to be simulating, and I did it with a calculator, and I wrote there what I did it with. I used randint 0 to 9, or my minimum, my maximum, and then I generated 6 numbers at a time, and I did it 20 different times, and here are my results. Now notice the numbers that you see for each trial represents the number of correct questions that I got. So you can see in question 1, or trial 1, I got 6 right. On trial 2, I got 5 right, and so forth. And here are the 20 trials that I did. And for me, I really didn't get that many correct. I got 3 out of my 20. And I should have gotten about a quarter of them right. So I should have gotten more along the lines of 5 correct. But it's a simulation. It plays to probability, and things work out sometimes one way and sometimes another way. All right, and so let's kind of move on to the next part. And so really our part 6 was to calculate the number that we're going to be doing. This is the analysis portion. And I wanted to take the number of answers or the number of trials that I got all 6 questions correct, divide that by the total number of trials that I did, so 3 out of 20 turns out to be 15%. And then question number 7 is basically take my numbers and my context and put it into a plain English kind of solution in context of the problem. And so we're talking about how many questions. The original statement was what's the probability that you get all the questions right. And so based on my results, I would expect to get all the questions right about 15% of the time. And this is what I expect you to be able to do. On Wednesday, we will be having a quiz, and this is the kind of scenario that you're going to be running through. The only other thing I would be careful about is you'll have to use a random number table as well. So when you're using a random number table, it's actually fairly easy to do that. So let's do one more example like that and we'll be done. Okay, here we have an example where we're talking about an elementary school teacher, 25 students. Basically, the teacher wants the first numbers of the states to be given out, and we want to figure out which kid gets which state. Okay, so in part A, it says which 2 state numbers does the first student get? Let me magnify this just a little bit. Okay, and we have a set of random digits here, and what we wanted to be able to do is it says which 2 state numbers does the first student get, and so notice right here we're only going from 1 to 50. So if we kind of come down and look at our numbers, we're going to be using 45. I can't use 92. We'll use 10. So our first 2 state numbers would be 45 and 10. Now notice these are grouped in 5s. You see here 5 here and 5 here. The only reason they do that is to help you to follow, kind of be organized. If they strung it all together, you could get lost really easily and you wouldn't know where you were. So if we continue this process on, then 17, then now I can't give 10 out here, right? Because one person can't get the same state twice, or 2 different states. 2 different people can't get the same state. So we skip over that number. So the repeats here aren't allowed, and the numbers from 51 to 99 aren't allowed. So you have to be careful about what numbers show up. So kind of keep on going. I'm just kind of running through the whole process. And 23 and 70 would be off. So really, using the numbers we have here, the only thing I can actually get is 45, 10, 17, 22, and 23. So those are the only, and that's how you would do that. For us, if you use the same number scheme here, and let me erase all that. If you use that same, if we do that on the last example we used, representing the questions and the multiple choice results, then if we look at the first 6 numbers, which would be here, that would mean that out of this you had 1, 2, 3, 4. So actually you had 5 right in this example. If you look at the next example, next set of 6 numbers, so that would be, I would actually have gotten 6 right for that one. The next set is 3 and 3. We have 1, so we have 4 correct in that one. So hopefully that makes sense about how to use a random number table. And you would have, if you had that number table, you would have simply just kind of gone down the list and marking off every 6th number and then seeing how many numbers from 0 to 7 you had in that list and counted the correct numbers. Otherwise it would have been pretty straightforward. Alright, so that's using a number line. Let's see. The numbers, I'm going to put up a set of questions on Classroom, or they might have printed them off for you. Either way, it really wouldn't matter. But I want you to write these down. These are the numbers I want you to do out of the whole problem. There's actually 18 problems on the whole page. You are definitely not required to do all 18. But I've picked out a few. Picked out 6 problems for you to do. Number 8 is like the question that we just got through doing. And then I believe number 17 is about redoing like a full simulation. And 17 is probably the most important question, because when we do a quiz, that kind of encompasses the whole scheme about learning about simulations. So make sure you can do number 17 as well, especially number 17. So take the rest of the time in class to complete all these. If you need extra practice after 17, then you can do 18 as well. It kind of is just a continuation from number 17. Just in case you finish early, there's plenty of other problems to do, so nobody should be sitting around doing nothing. Okay, if you have any questions, please feel free to email me at any point during the class. If you have any questions even after school, please email me. We'll talk about this on Tuesday, and then Wednesday will be our quiz. So see you tomorrow.